Hello everyone. The topic for today's chapter DC circuit analysis is numerical on simple DC circuits. As you know, our subject is BEEE, that is Basic Electrical and Electronics Engineering, and its subject code in RGPV is BT 104, and the subject is in first year BTech program. So as we have already discussed the Ohm's law and the combination of elements, now we'll be taking up the numericals on that. Well, let's see the first example. This is a circuit diagram which is being shown here. We are having a 250 volt voltage source here, and we are having four resistances of value 15 ohms, 10 ohms, 10 ohms, and 5 ohms each. What we need to find out, the problem in this given numerical is you have to find out the power loss in 15 ohm resistor. So for getting the power loss, first of all, we need to reduce this circuit, and we need to find out the current flowing the 15 ohm resistance first, then we'll find out the power. So let's proceed. As we already know that if you can see, I have seen in the left side slides, we can take the previous slide also. So in this function, as we already know that in this particular numerical, this 10 ohm and 10 ohm resistances are in parallel, right? So we can reduce it by calculation. So 10 ohm and 10 ohm in parallel will give you 5 ohm. Yes, as we already know that formula for the same is 10 into 10 upon 10 plus 10. So what we'll be getting? We'll be getting 5 ohms here. So now the 15 ohm, 5 ohm and 5 ohm resistances are in series. And as we already know that voltage always emerges from positive side of the potential difference, then the current will be flowing through clock in this particular loop is in clockwise direction. So the clockwise current which is flowing here, that is loop current, is current I. Now we need to sum up, reduce these three resistances into a single resistance. So now this 15, 5 and 5 ohms are in series, and we already know that in series we add up the resistances. So we'll be having R equivalent as 15 plus 5 is equals to 25 ohms. We'll be getting as R equivalent, that is equivalent resistance. And as we already know Ohm's law is equals to I is equals to V by R in a particular loop. So V here is 25 volts. Sorry, 250 volts is the voltage here, and the equivalent resistance is 25 ohms. So current would be V by R, that is 250 by 25, that is 10 ampere. So this is our first example. This is the simplest one. Now next proceed to the further step of the numerical. Now we have find out the current. Now we have to find out the power across it. So how to get the power here? For getting power, we need to calculate the formula by the using power. So formula for power is equals to V into I. Power is equals to V into I. And we already know that by Ohm's law, V is equals to I into R. So the formula would be I square R in nutshell. So for the power formula, we'll having I square R, and the unit for the power would be watts. And we have already calculated the current, like 10 ohms, we have 10 ampere we have calculated. So power would be 10 amperes square into 15, that is resistance. The resistance through which we need to calculate power is 15 ohms. So we take up this resistance. So power is 10 square into 15 watts, that is 1500. So now we have find out the answer for this problem. That was to find out the power across the 15 ohm resistance which is given, right? Now we'll take up second example. In second example, as it has been written here, there are two resistances of 20 ohms and 30 ohms in parallel. As we can see in diagram also, these two parallel resistances are further connected in series with this 15 ohm resistance. If the current flowing through 15 ohm resistance is 3 ampere, that has been given. So what we need to find out? We need to find out the three things. Find the current flowing through 20 ohm resistance, that is I1, and 30 ohm resistance, that is I2. Second, we need to calculate the voltage across the whole circuit, that is the unknown voltage which is showing here as V. And then third, we need the total power consumed, right? So we'll take up the questions simultaneously, side by side. So yes, we have already just as we have done in last numerical, we need to simplify this circuit into one resistance, right? We need to reduce these three circuits into one resistance, and that would be your R equivalent, right? Or as we know that this RAB, what would be RAB? RAB would be the equivalent resistance of these two parallel circuits, right? So 20 and 30 would be in parallel, and when we'll be solving this, we'll get a 12 volt resistance. How? 20 into 30 upon 20 plus 30 will be taking up like this. So 20 into 30 would be 600 upon 20 plus 30, that is 50. So 600 by 50 would be 12 ohm resistance. That would be resistance RAB. Now this 12 ohm resistance would be in series with this 15 ohm resistance. So what we would be having? We would be having the total equivalent resistance of the circuit as 12 plus 15, that is 25 ohms would be the equivalent resistance. And now the voltage across the whole circuit would be, right? As we already know that the current which is flowing through this element 15 ohm is 3 ampere, and we as we already know that I1 and I2 would be I1 plus I2 would give you the 3 ampere. That means I1 plus I2 is equals to 3 amperes, and that is the current of this whole circuit, right? So current I is equals to 3 ampere, that is loop current of this given circuit. And we already know Ohm's law is everywhere. So V is equals to I into R. And here we are taking R equivalent because we have to find out the voltage across the whole circuit. So voltage across the whole, for calculating voltage across these two terminals, plus and minus, and the voltage V which has been seen here, we need to calculate the R equivalent multiplied by current. So current would be 3 amperes here, and R equivalent would be 27 ohms as we have calculated here. So voltage would be 3 into 27, that is 81 volts. So first problem has been solved. Now this let's move to the further problems. We need to find out the total power consumed. So as we have already seen in previous numerical, the power formula for power would be power is equals to V into I. So we have calculated V, that is 81 volts, and we have calculated current, that is 3 amperes. So the power would be 243 watts, and we get it from multiplying 3 by 81. Now we need to find out the voltage drop across each of the resistances which are connected in parallel, that is 20 ohm and 30 ohm. So for that, we already know that VAB, that means voltage across this AB point, would be the current multiplied by the equivalent resistance RAB among these two. So the equivalent voltage across AB would be current multiplied by RAB. Current is 3 amperes, we have already calculated, and RAB also we have calculated, that is 12 ohms. So 12 into 3 gives you 36 volts. That is the voltage across these 2 points, that is VAB. This is the potential difference across point A and point B. Now we need to find out the current I1 which is flowing through 20 ohm resistance, and I2 which is flowing through the 30 ohm resistance. So we already know that VAB and Ohm's law is there again. So I is equals to VAB upon this resistance 20 volts. So I1 would be VAB upon R1, that is 20 ohms. So VAB is 36. 36 by R1 is 20. So 36 by 20 would be 1.8 amperes. And current through 30 ohm resistance would be VAB upon 30. That is 36 upon 30. Resistance R2 is 30 here. So 36 upon 30, when we'll calculate, it would be 1.2 ampere. So that is how we calculated. We calculated the current flowing through 20 ohm and 30 ohm. We have calculated the voltage across the whole circuit, and we have calculated the total power consumed across the circuit too. Okay, now let's move towards the third numerical. And here it is. A DC circuit comprises of two resistors, A of value 25 ohm and B of unknown value, connected in parallel. This must be an interesting question. Together with a third resistance C of value 5 ohm, connected in series with the parallel branch. Now we'll depict it numerically also in the form of circuit diagram. Now we need to find out the voltage to be applied across the whole circuit, and the value of resistor B if the potential difference across C is 90 volts and the total power consumed is 4320 watts. So here is the circuit diagram. Here is the circuit diagram. 25 ohms and R resistance, that is unknown resistance, are connected in parallel along with the series resistance 5, which is depicted as resistance C. and the voltage across this resistance C has been given as 90 volt, and we need to find out the voltage across this circuit, and the power consumed across the whole circuit has been given here 4320 watts, right? So first of all, we need to write all the data which has been given here. While you're solving any question and writing it in answer sheet, you first of all need to write the given data first, then you have to start putting in the numerical and you should go further, right? So we have mark the current here. As we already know, voltage के positive side से हमेशा current निकलता है. Current always emerges from the positive side of potential difference. So here the current is going like in clockwise direction, and this current would be again divided into A and B resistances, and then it further get united here, and that means I1 and I2 would be added here, and the same would be flowing into the C and comes back to the negative terminal of voltage, right? And so the resistance C, which is 5 ohms, having the potential difference of 90 volts across it, and we need to find out the current. So for finding out the current through C, that is 5 ohm resistance, we need to divide it simply by 90. We need to divide the resistance by the potential difference value. So the current flowing through C would be I, and I would be V by R, Ohm's law again. So I is equals to V by R, and voltage drop across resistor is 90 volt, and the value of resistor C is 5 ohm. So 90 by 5 will give you 18 ampere current, right? So the current flowing through C, that is 5 ohm resistance, is 18 ampere. Now we need to find out the total voltage across the circuit, that is V, which has been given here. So if we know that already P is equals to V into I, power is equals to voltage into current. So we have power already given in the question. So what we need to find out? We need to find out the voltage. Current we have already calculated. So we'll be putting up the 18 ampere current here. So total power consumed is already given in the question, 4320 watt. And the current through the circuit we have just calculated, that is 18 ampere. So power upon current will give you the voltage, that is 240 volts. So 240 volt voltage has been calculated, right? So next we need to find out the unknown resistance R. So how we would calculate it? So for that we need to find out the potential difference across these 2 points. This point supposed to be point A, and that should be kept here, and this point is point B, which is supposed to be here. So what we need to do, we need to find out the voltage. We need to find out this voltage AB, and then similarly we can calculate by applying the formula, the resistance we can calculate easily, right? So what we know that the total resistance across the circuit is 240 volt, and the voltage across C is 90 volts. So the remaining voltage, which is voltage AB, would be V minus 90, that is 240 minus 90, right? Because we know that voltage always add up in series. So this VAB would be 90, that is voltage across parallel combination would be 240 minus 90. Now the current flowing this 25 ohm, if we'll calculate, that would be 150, the voltage upon 25, that is 150 upon 25, that is 6 ampere. So 6 ampere current would be flowing here, and here the current which is flowing here I through C is 18. So the current which is being flowing through this R resistance would be definitely 18 minus 6, that is 12 amperes. Why? Because we know that current always split. This current I is 18, and this splits into this branch I1 and I2. Here it is going 6. So obviously from 18, 6 would be reduced, and the rest of 20 amperes would be flowing through this R, right? So how we can calculate the R now? Again, Ohm's law, R is equals to V by I. So voltage across the resistance R is 150, as these two are in parallel. So the parallel branch voltage is 150 volts, and the current which is flowing through this resistance is 12 amperes. So 150 upon 12 will give you 12.5 ohms resistance. So this is a interesting numerical. So I hope you all get the basic concepts of the combination of elements and equivalent circuit and the Ohm's law. So all these 3 examples will help you to find out the solving technique for the next few numericals also. So practice all these numerical. So now we have ended up the numerical problems on simple DC circuit. Thank you.